So here we have to have 3 and 5 included in this group that we're selecting from 8 of these numbers. And so we have to count the numbers that are 3 or more. So we have one more choice here. We could have 2 more, 3 more, 4 more, 5 more, and 6 more. So we can focus on the remaining digits other than 3 and 5. So that would be 1, 2, 4, 6, 7, and 8. This piece is constant. So all I need to figure out is how many of these groups that I can select with 1 element, 2 element, 3 element, 4, 5, 6 from this set of 6. And the condition is 7 and 8 cannot be together. Now, if we have 6 elements, the number of ways we can select these elements 1, 2 from a pool of 6 is 2 to the 6 minus 1. That minus 1 is to exclude the null set. So if we just compute that, this will be 63. So that's the all possible. So that means, this would include 1, 2, 4, 6, 7, 8. This set here would be 1, 2, 1, 6, so on and so forth. So what we'll do is we will actually subtract the ones, meaning we'll do the complementary event, which is where 7 and 8 are together, and we're going to count those and then subtract that from 63. That would give me then the number of groups that will have either 7 or 7 or 8. So you can't have both of them together. So what we'll do is, if we look at the first one, a single element, you can't have 7 and 8 are together, so that's going to be 0, meaning there's no case here where 7 and 8 are together. If you look for the 2 elements, yes, if both 7 and 8 are together, that's one case, so that would be just 1. And if you have 3 elements, if you have 7 and 8 together, then we have one spot to fill, and we'll be selecting it from the other 4. So I'll have 4 choices. So what I'm really doing here is this set example would be a group 7, 8, 6, for example. And I'm sort of pairing it with 3 and 5. And I'm subtracting that from 63 to give me the sets that do not have 7 and 8 together. So I'm doing the complementary event. Same thing if we had 4 of these. So 7 and 8 are already there. How many ways I can select 2 elements from a set of 4? So that's 4C2, which is 6. And then next is if I had 5. I'm looking at this one. Now I'm selecting 3 elements from a group of 4. So this is 4C3, which is 4. And then finally, we're looking at 6 elements. We're selecting 4 from a set of 4, which is just 1. So how many of these sets have 7 and 8 together? 1 plus 4, 5, plus 6, 11, plus 4, 15, plus 1, 16. So 16 of those have 7 and 8 together, which means 63 minus 16, 47, will not have 7 and 8 together. They might have just 7 or 8, but not both at the same time. So this was easier to do looking at the complementary event. You can also go it directly. You just have to kind of write down the cases. You will get the same answer. And I would urge you to do it that way too, so that you're comfortable doing the computation both ways. And so you kind of understand what the question is about. So to summarize, the answer is 47.